All right, first thing I need you to know is that you're going to set up these problems the same way that you set up the motion problems that we did a while back, which means we're going to read the problem, highlight the information, list the information. Write the formula, substitute numbers in the formula. Unfortunately, it will not record the facial expression that I just gave you. Yippee. Yeah, yippee for you. All right, so number one is the first one that we're going to do together. It says a baseball with a mass of 0.8 kilograms is given an acceleration of 20 meters per second squared. How much force was applied to the ball? All right, so first of all, you have 0.8 kilograms, highlight that. You have 20 meters per second squared, and it asks how much force. So you want to put force equals question mark, mass equals 0.8 kilograms, and you want to put acceleration equals 20 meters per second squared. So you're going to list everything, list what you know and list what you don't know. You may have to go back to your notes to look in your notes to find the formulas, but since I know all the formulas, here we go. Force is equal to mass times acceleration. So I'm going to write my formula. I'm going to write my formula again, this time with the numbers substituted in. 0.8 kilograms for mass, 20 meters per second squared for acceleration. And then, unless you can do this in your head, you have to show me the work. But there's some little handy-dandy math tricks, and hopefully you know a few of them. 8 times 2 is 16. 8 times 20 would be 160. Well, 0.8 times 20 is 16. So our force is 16 newtons. Now notice they didn't give you a direction which way the ball went, so just don't worry about that. I mean, force is a vector quantity, but direction wasn't given to you, so don't worry. So just box your answer, and you're done.
Can that only go up to 15 minutes?
Yeah. Okay, next one. Go down to number 6. Ms. Goff, we really appreciate you doing number 6 because it says it requires 2 calculations. But there's a back. Yes, there is a back. But we're going to do one on the back too. We're doing 30% of this together, so stop complaining. How about a no? All right, number 6. How much force is required to stop a 1,200 kilogram car in 2 seconds if the car is traveling at a velocity of 22 meters per second? Hint, this is a problem that requires 2 calculations. All right, so you're being asked to find how much force. So we start out by listing what we know and what we don't know. Force equals question mark. We have mass, which is, how do you know that that's the mass? Because the kilograms tells you it's mass. Okay, we have time, which is 2 seconds. We have, Ms. Goff, how are we going to do this? We have a final velocity and an initial velocity. Initial velocity is actually 22. Anybody know what the final velocity is?
0.
Yes, it's 0. How do you know it's 0? Because it stops. It doesn't give you that number, but, you know, if it's stopped. Up. You want me to move it up? There we go. Is that good? Ah! Okay, hang on. Let me move my paper. All right, are we good? Okay, so we have an initial velocity of 22. We have a final velocity of 0 because it says it stops. And so the other thing we actually have to find before we can calculate force is we've got to know what the acceleration is. Would y'all agree with that? Even though it's not stated in the problem, that's the first calculation that we have to do. So our first calculation, I know, these problems are hilarious. Find acceleration. And we have to go back to our old formula for acceleration. Acceleration is equal to a change in velocity divided by time. How much did the velocity change?
22.
By 22 meters per second, because it started at 22 and it ended up at 0. Okay? And how much time did that take? 2 seconds. What's 22 divided by 2? 11 is our acceleration, 11 meters per second squared. Is that our final answer?
No.
Nope, because we were asked to find force. But then we go find force. And we're going to say force equals mass times acceleration. It doesn't tell you that it's net force, but assume it's net force unless they tell you differently. So force equals mass, which is 1,200 kilograms, times 11 meters per second squared. And if you guys know your multiplication tables, 12 times 11 is 132, and just stick the 2 zeros back on there. So this is 13,200 newtons
Is that a lot?
of force. Well, there's 4.45 newtons per pound, so
A lot.
What are the units
on the acceleration, the units are meters per second squared.
no, the 11 on the force. F equals 1,200 kilograms and then divided by what?
This says force is equal to 1,200 kilograms times 11 meters per second squared.
I can do that.
Everybody hunky-dory on that one? Okay, flip. Find number 9. Hint, this is a multi-step problem. Most of the ones on the back are. But I'm doing 2 of them for you, so I mean, come on. Shh.
Two on the back for it?
No, 2 multi-step problems for you. Thank you, Miss Goff.
Thank you.
Yes, you're welcome. All right, number 9. A racing car weighs 8,820 newtons. How much force must be produced by the racing car engine to move the car from rest to a speed of 40 meters per second in 4 seconds? Hint, this is a multi-step problem. Okay, so first of all, we have the weight of the car, which is 8,820 newtons. What else do we have? We want to know how much force do we need to apply. We do have a speed. Technically, y'all have a formula that involves initial and final velocity, but we can call it initial and final speed. That's okay. From rest to a speed of 40 meters per second. There you go. So initial velocity is actually 0. I'm going to go ahead and call it velocity. What's final velocity? 40 meters per second. Time is 4 seconds. What do we need in order to calculate force? Yeah, well, we're going to use this formula. We're going to use force is equal to mass times acceleration, and we don't have either one of those. Oops. Ooh, how do we find them? Jordan, shh.
Find the weight. You find the mass by weight times gravity.
Weight divided by gravity will give you mass.
And then
Change in velocity divided by time will give you acceleration. All right. It sounds like I got interrupted. Yep. Done.